For Geometry, Unit 7, Day 10 Worksheet. So here, very similar to our notes, we're going to solve for AC, which is the total length, CD, which is the total vertical height, and BE, which is the support. So we can solve for any of those three letters at any time. Let's solve for BE, the support. So I think it's always helpful to redraw the triangle. We have a 42-degree angle. We're trying to solve for BE. BE is the opposite side, and we know that this length is 5. So opposite and adjacent. So that tells us, since we're going to use SOHCAHTOA to help us identify which trig function to use, opposite and adjacent, opposite hypotenuse, adjacent hypotenuse, opposite adjacent. So we're going to use tangent of 42 degrees to equal the opposite side over the adjacent side. Place it over 1 so we can cross multiply. 5 times the tangent of 42 to equal BE. And when we look for BE, we're going to get, let's try that with our calculator, 5 times the tangent of 42. We get 4.502. So 4.50 would be fine. That's actually the hundredths. 2 is below 5, so we don't round up at all. That's BE. No need for the 0 here, but if it says hundredth, let's be sure to put a hundredth value down. So that's BE. Next we'll try to find CD. CD is part of the larger triangle. We have a 42. Now our long leg is a total of 5 and 3, which is 8. And we're looking for C to D. That's considered the opposite of our angle. And we also have the adjacent information. So just like before, opposite over adjacent is tangent of 42 equals CD over 8. Cross multiply. So this is 8 times the tangent of 42. And when we calculate for CD, we get 7.20. Then our last part, we're solving for AC. We have the big triangle. We still know that this length, which is called the adjacent one, is 8. We're solving for AC, which is the hypotenuse. So we're working with adjacent hypotenuse. So we're working with cosine of 42 degrees. Equals adjacent over hypotenuse, which is CA, AC. Cross multiply. Now notice this time we're trying to get AC by itself, so we're going to divide by the cosine of 42. And when solving for that, we come up with 10.77. Jennifer is designing a quilt pattern. She wants to put right triangles together with one leg being 4 centimeters and one acute angle of being 40. How long are the other two sides? Well, one thing that this hasn't made clear, it hasn't made clear if the 4 centimeters is the opposite side or if it's the adjacent side. It hasn't made clear if it's a shorter leg or the longer leg. just as one of the legs, and it would matter. It would matter if it's the shorter or longer. So just for fun, let's throw it over here. So when we're calculating now, we're going to solve for this opposite side. We'll call it A, and this hypotenuse, which we'll call B. So we got to solve for A and B. Well, the information they have given us is the adjacent. Looking for the opposite, or we're looking for the hypotenuse. You can't find them both at the same time, so don't use sine, opposite over hypotenuse. Those are two unknowns. We're going to use cosine. It's good to write SOHCAHTOA out for most every problem to be sure that you're real familiar with how to write it and spell it and make use of it. So adjacent hypotenuse is cosine. The adjacent is 4. The hypotenuses are unknown. So we'll put that over 1 and cross multiply. We'll divide by the cosine of 40. So now the hypotenuse is by itself. And when we divide 4 by the cosine of 40, we get 5.22, and these are centimeters. Now we're going to look for the opposite. So I'm not going to use the 522. I'm going to use opposite over hypotenuse. Well, no, we're not solving for the hypotenuse right now. We're using opposite over adjacent. Opposite over adjacent is OA, which is tangent. The opposite side is our unknown. And the adjacent side is 4. So our opposite side is going to be 4 times the tangent of, well, it's 4D, not 42. That was the other problem. So when we multiply that out, we're going to get 10.77. Jonathan wants to make a perennial garden in the shape of a rhombus. He decides to make one of the angles 36 and the long diagonal 12 feet. How long will each side of the garden be? And how long is the shorter diagonal? So again, it sounds very much like our notes. So we have this rhombus. We know we have a 36-degree angle here. We have a long diagonal, which is 12 feet. When we throw in this other diagonal, we know that the 12 feet gets split into two equal pieces, in fact. So if 12 is the total length, the one triangle that we're looking at here is going to have a 6-foot leg. The 36 is going to be cut into 2 equal pieces down here, so this is going to become 18. So to figure out the length of one of the sides, we need to identify that one of the sides would be the hypotenuse of this right triangle. So if this is the adjacent side, it's next to the 18, and this is the hypotenuse, it's across from the 90. We're going to think about SOHCAHTOA to help determine which trig function to use. Adjacent and hypotenuse is cosine. So we'll put it over 1 and cross multiply. We'll divide by the cosine of 18. So the hypotenuse is going to be 6 times, or actually 6 divided by, which comes out to be 6.31. And we know that that's feet. Diagonals are perpendicular to each other. That's what made it a right triangle. The diagonals bisected each other, and that's what cut the 12 in half to make it 6. But now if we're trying to figure out what the other diagonal length is, that's half of the total diagonal. So for us to figure out the opposite side, we need to use opposite over the adjacent. Opposite over adjacent. So opposite over adjacent is tangent. Tangent of 18, the opposite side over the adjacent side. So when we take our calculation of 6 times the tangent of 18, we're going to get 1.149, so 1.949, so we're going to get 1.95. That's the opposite side of this triangle, and we're going to have to take this to figure out the diagonal times 2. Well, nope. The diagonal itself equals 2 times 1.95. So that is 0.05 away, so it's going to be 0.1 now away from becoming 4. So 3.90. And those would be feet. That would be the other diagonal. A surveyor is standing 50 feet from the center of the base of a tree. The surveyor measures the angle of elevation. Remember, that's the measurement upwards, like an elevator, measured up from a horizontal, to the top of the tree, and that's 71.5. How tall is the tree? So we're trying to figure out h for the height of the tree. So we're working with the opposite information, and we have the adjacent information. So again, using SOHCAHTOA, we know that tangent of 71.5 is the opposite, which is h, over the adjacent, which is 50. So 50 times the tangent of 71.5, that's going to be the height of this tree, which comes out to be 149.43. feet tall. A biologist wants to know the width of a river in order to properly set instruments for studying the pollutants in the water. He first takes a sighting, that's point C, directly across from where he's standing, straight across, so perpendicular. He walks 100 feet parallel to it, so here we have 100 feet. And he figures that that's a 22-degree angle when you come back to it. So now we can calculate how wide this river is. So we're trying to figure out what is opposite that 22. So using the concept of SOHCAHTOA, which is the information that we have is opposite, and when we're next to the angle, that's called adjacent. So opposite and adjacent, the O and the A is tangent. So the opposite side is our unknown, and the adjacent side is the 100. Place it over 1 and multiply. And when we calculate what this opposite side is, we're going to see that we get 40.40, and that's going to be feet. And that's how wide the river is. Here's our last question. It leads right into what we'll be doing tomorrow. Okay, we're going to work on trying to figure out an angle. Okay, totally understandable if you have trouble solving for this one. Okay, Steve is bored with symmetry, because symmetry is what all this trigonometry is about. He's making a triangular deck on the side of his house as shown. He wants angle G to be a right angle, and he wants angle F to be 3/5. He wants to use the entire side of the house, which is 30 feet. So this is 30 feet. And we're working with, should be tangent, oh there it is. He wants the tangent of F to be 3/5. Okay, so if the tangent, this was similar to our notes that we stayed away from, but the tangent, what was different about the notes is that the notes gave us an angle also. So if we had the angle, we could go ahead and figure out what the lengths of our sides were. So we need to figure out the lengths of these sides. So the tangent of F equals 3/5. Now there should be a way for us to figure out what angle makes a 0.6. 3 divided by 5 is 0.6. If we can figure out what angle makes 0.6, then we should be able to figure out, well, the other way around. If we know that a certain angle has a tangent of 0.6, and we should be able to work that backwards. So to work that backwards, think about kind of like dividing by tangent. We want F to stay where it's at. So it's called inverse. We're going to do tangent inverse of 0.6, and that's going to give us the measurement of angle F. So in your calculator, if you look at inverse, you'll see that those are written right above sine, cosine, and tangent. It has the little -1. So in this case, we're doing inverse of tangent, so we'll hit shift tangent, and we'll put in our 0.6, or 3 divided by 5. And that should give us 30.96. Now, since we have that angle, now we can go through and solve for the other missing sides. So to solve for these other missing sides, we could use sine of our 30.96 equals the opposite side over the hypotenuse, cross multiply, and if we're going to use actually just 30.96 and not the whole value, it would be best to use that whole value. If we're going to use just a 30.96, then 30 times the sine of 30.96 gives us 1543. That's the opposite side. The adjacent side, the one next to the 3096, would be cosine of 3096 equals this adjacent side over the hypotenuse. So, over 1, cross multiply, so 30 times the cosine of 3096 equals the adjacent side. So we'll take 30 times the cosine of 3096 and we get 2573, and that's feet for the adjacent side. Another possible way that we could go about solving this, option number 2, is to use our Pythagorean theorem. If we know that the tangent of f is opposite over adjacent, then we know that we're working with this right triangle that has a hypotenuse of 30. We have this angle of f. The opposite side is supposed to be, and the adjacent side have a reduced fraction of 3/5. So we could call this 3x and 5x, because most likely it's not 3 and 5, because that doesn't even make a triangle, 3, 5, and 30. So it's 3 times something and 5 times something. So in this case, we could use Pythagorean theorem, which is 3x squared plus 5x squared equals 30 squared. So that comes out to 9x squared, and 25x squared equals 900. So we have 34x squared. Then we would divide by 34 to figure out that x squared would come up to be approximately 2647. Let's see, 900, which is 30 squared, divided by 34 gives us our 2647. Now I'm going to use that real value, because I'm going to take the square root of 2647, but I'm going to take it of the whole value, so the square root of the answer, and that gives me that x is 5.144. Now that's the ratio that we have here. So the side opposite would be 3 times that much. So 3 times the answer would give us 1543. Okay, so now I'm going to divide that by 3 just so we have that number back again, that 5.144. Now we're going to say 5 times that answer. So if you look here, the 1543 matched up exactly. The 2573, 72, that came up really close to each other. So it's just a different way that you can look at ways to solve a problem. There's typically more than one way in mathematics.